Hello, everyone. I'm Paul Drabble, Senior Marketing Manager at Delta Q Technologies, part of the ZAPI group of companies. I'd like to extend a warm welcome to everyone tuning in today and let you know that this session is being recorded and will be available to watch on demand in the future. If you have any questions during the session, please add them to the question and answer tab in the top right of your screen. Note that your questions will be sent privately. With that, I would like to introduce our speakers today. It's my pleasure to welcome Shuang Zhao, Safety Manager at InMotion. He'll be speaking today about the ISO standard pertaining to the design thinking for the material handling and construction equipment industries. Welcome, Shuang. The session is now yours.
Hello everybody. Welcome to my session. So I'm the safety manager at InMotion Technologies. I've been started my job here since year 2018, and have been appointed as the safety manager since 2 years ago. So my focus is mainly on the system development according to ISO 26262 and also ISO 13849 standard. So today I'm going to talk about the developing subsystems according to the safety standard. So as you know that this is a very big topic to be covered in such a short presentation. So I will be sharing my personal understandings and also my experience with you today at a higher level of the development. So if you have any questions, please feel free to leave them in the chat, and I will try to answer them to my best knowledge later. So today I'm going to talk about some points. First, I would like to start from explaining you what is this ISO 13849 standard. It's my personal understanding and interpretation. There is some common misunderstandings that I've heard during the jobs from different people, from our OEMs and also from colleagues. So something that I feel is very noteworthy to share with you. And then I will also would like to show you some systematic thinking approach to facilitate the development of the subsystem according to the standard. Also, I would like to talk about the key steps that I think is fairly important for us to consider as a subsystem supplier. Some challenges that we have faced over the years, and in the end, a short conclusion. So ISO 13849, so what is that? So it is an international standard that focuses on the safety of machinery and related equipment. As you see on the screen is a list of some examples, which are the functional safety standards applicable to an electrical or electronic device. So ISO 13849 is just one of them, and it's a focus on the development of machines. And similarly, for automotive industry, we have the ISO 26262 standard to follow. So if you have worked with other functional safety standards, then you will find that the core objectives of all the functional safety standards are quite similar. All of them are talking about how to identify hazards, how to evaluate the risks, and how to mitigate them by applying a safety concept, using safety functions or safety mechanisms. It really depends on what safety standard you are talking about. And all those standards, they provide guidance to facilitate the design of the safety-related control systems. Some standards provide very detailed and thorough methodologies recommended to the engineers, and some standards, they have a higher level guidance of such development. and referring to other safety standards. And in 13A49, something is unique, which is the performance level. It is something very similar to the safety integrity level in IEC 61508 standard or the ASIL level in 26262 standard. Something very obvious when you open the book. However, there are some details behind those words. So I would like to share you something that is good to know. So if you have not ever worked with a functional safety standard, you may find all those standards are quite overwhelming. You will find hundreds of requirements, and some of them are quite okay to follow, but many of them are really difficult to understand. Or maybe at the beginning you feel like you can interpret all those requirements. However, when you really start to develop your system, it becomes really, really troublesome. And one of the reasons is that people miss a very important point of the functional safety standards. That is the scope of those standards. Either you are OEM developing a vehicle or a machine, or you are subsystem provider that is making a device for the OEM. So that safety standard applies to both of the parties. But not all the requirements are applicable to both parties. So it's good to know that 13849 applies to manufacturers of machines, equipment, or systems incorporating control systems. So it applies both to the OEMs and also for the subsystem suppliers like ZAPI Group. The hazards are identified at the machine level. So often companies start to apply the standard and trying to identify hazards and try to mitigate, identify the risks. However, those people are subsystem providers, so then they may find it's really difficult to understand how does it work. But actually, it's not for the subsystem supplier to identify the hazards and mitigate them. It is the OEM's responsibility. Risk reduction. A very good thing in this standard is that the risk reduction can be done by using the safety function and other measures, which means that not all the risk needs to be mitigated by introducing a very complicated solution in electrical and electronic equipment. So the OEM can find other approach to mitigate the risk, to lower down the required performance level, because that performance level is not just a number. There are hundreds of requirements behind it, and those requirements look very different. Depends on the performance level you need to reach. So it's fairly important to really understand the terminologies in the safety standard, not only in ISO 13849, in all of them. In this standard, it's talking about system, subsystem, and even subsystem elements. So when you start to work, you will soon realize that the safety functions are implemented by the system, and the subsystem, like ZAPI's device, most likely are required to implement subfunctions, which is a part of the safety function. And there are very different requirements from the standard for a safety function development and for the subfunction development. There are even greater differences when the supplier actually is only providing a solution for a subsystem element solution. I will talk about it briefly in the presentation. So design thinking approach. So it's very important to have a systematic approach for everything when you work with a functional safety standard. So first, I would like to just show you briefly how should we start the design work? So once you have a interested customer who would like to start up a project according to the standard, what should we do? So first one, communication. Actually, I will talk about the communication over and over in this presentation because personally, I find it's the most important thing to talk about. So in an ideal case, the OEM shall provide all the information required for us to interpret their safety concept. As I mentioned before, they are typically responsible to identify hazards and come up with a system level solution. So they have their concerned hazards. And for machine applications, as you know, there are just so many different kinds of machines, and different machines have different concerns, like cutting a finger or crash into a wall or generate too much heat, etc. Even with the same device they are using, they will have different hazards. So as a subsystem provider, it's very important for us to understand what is the root cause for the OEM to ask for a functional safety. And second is that it's very good to have the opportunity to be involved in the very early stage of a functional safety development. So we can contribute a lot to impact the functional safety design at the machine level. As I said before, this standard allows you to mitigate the risk by using safety function plus other measures. So as a subsystem provider, we usually have lots of application projects. So we have learned a lot of experiences from those projects. So in some cases, we can provide very good inputs to the OEMs to remind them that, okay, maybe there are something better, cheaper to use to reduce the risk level. So when you are buying a device from us, you don't need to have a performance level E. Maybe introducing a simple plastic cover, you only need a performance level C device. And that means a lot cost reduction. And also, if we can be involved in this stage, then we can gain a much better understanding of the market needs. And then once we have communicated with the customer, received the safety requirements from the customer, it's very important to have a handshake to make sure that we have understood the customer's needs in a very good level. Otherwise, it may result in a big project delay and also a cost increase. And after we have understand what the customer really wants, now it's time to think about how should we design our system to fulfill the safety requirements we have received from the customer. So as I said, in most of the cases, the customer is asking a subsystem provider to implement one or several sub-functions. So based on the information we collect, we can make proposals how to design a sub-function. Of course, there are some very competent customers. They have done such projects before, so already at early stage, they will be able to decompose their safety concepts and start to define sub-functions and write very good requirements for us. So that will be a very good customer to us. But in most of the cases, we have to come up with proposals what we think should be a sub-function or sub-functions. And so after the design, again, we need to communicate to the OEMs to have a really solid handshake, just to make sure that the customer really understand our technical solution, so they can validate their functional safety concept at the machine level. And according to the experience, it's very good to develop a prototype as early as possible. This prototype doesn't need to contain all the safety measures. However, it shall be able to provide the functions that the customer is really waiting to test. Because this standard is talking about the safety functions, so they expect the system to behave in a certain way. However, when they specify the safety functions, it could be just from a brainstorming. So sometimes there are some aspects that they have not thought about. So it will be a really great help if the subsystem provider can provide a very quick prototyping opportunity to the system integrators. And tests. Tests is super important for a functional safety project. So basically, no matter what we do, there should be a test to verify the things that we just designed or implemented. It's really good to have this kind of mindset. So by doing the tests, we can get quick feedback, especially the things that doesn't work. So then we can come back to the drawing table and try to mitigate the problems. Sometimes we even have to go back to the customer to make other proposals. So sometimes they need to change their safety functions at a higher level. So in the previous slide, I was talking about the design approach, but actually for functional safety standard, the design is just a small part of the whole project. So all the functional safety standards, they usually specify tons of requirements about the processes, how to mitigate the systematic failures. So actually, in reality, it's very seldom that you have a problem caused by a random hardware failure. It's usually always related to the human errors. So there's a lot of work needs to be done from the organizational level all the way down to the discipline, apart from the designing phase. All functional safety standards will ask us to provide evidence at the end of the day. 13849 talks about validation. 26262 is talking about the safety case. Similar thing. So we have to show the evidence that our delivery is safe enough. So our delivery is not only a hardware plus software. It often contains tons of documentations. So it is really hard for the company to do this kind of alignment if this is your first time. So what we have learned is that it's not that difficult. It's very time consuming, that's true, but it's not as complicated as you think. So the first thing the organization needs to do is to identify all the requirements that are applicable to the company from the standards. All the companies shall already have a quality management system in place. This is a prerequisite to start a functional safety development. So then the next step is that the company shall align the process to produce artifacts that can fulfill all the identified requirements. And by doing that, you can show the evidence that the process is compliant to the standard. So then the discipline shall follow the process to produce the expected artifacts. And those artifacts are the evidence that I'm talking about. And for the company, we have to think about the future as well. So it's very important to have a competence development plan. we have to think about the life cycle of our product. It's usually developed to last for more than a decade. Things always happen. Maybe you have something need to be changed after 5 years of launch. After launching the product, then you need to make sure that the company still have the competence to analyze the changes, to implement the changes, and also to verify the changes. So it's super important to keep it in mind that while doing your developments, create guidelines along the way, and also summarize methodologies. So the newcomer can learn from the experienced engineers, and also the company is no longer tied to individuals. Again, understanding client requirements and the context. So if you are into the standard, then you will see that there are something that can simplify the development. One thing is this category classification for the subsystem. So the safety function, when it is decomposed to the subsystem, actually this category classification is not applicable to the system. So the OEM will only decompose the system into series connected subsystems. So we have to understand, is the customer asking us to implement subfunctions in a subsystem? In that case, if we choose to use the simplified approach, we shall argue what kind of category level our system is equivalent to. But there are other types of developments for very competent customer, as I said before. They may are looking for a subsystem element. They already have a category solution in their mind in their subsystem already. So when you are developing for such solution, actually you are only developing an element. So if you know the standard, then you see this architecture is for category 3 or 4. So if we are asked to develop such a part of the subfunction, then the requirements could be reduced significantly. So when you see the performance level from the customer, it could be extremely high, but actually the actual things we need to do is reduced. So it's kind of important to understand this at the very early of the development. So then we can come up with a more proper estimation of the cost of the project. One thing we have learned is that it's easier to understand the client requirements using a well-defined template. So you can always come up with a template for the safety function requirements or for the subfunction requirements. So as a company, you know what you are looking for. There are lots of attributes you would like to know, a lot of parameters you would like to know, and also the budgets that need to be understood. And agree on all deliverables. As I said before, when you do a functional safety project, your delivery is not just the hardware and the software. It's many things more. So typically, the customer will ask us to provide the documentations at some stage of the project. Some customers, they forget to mention it, and then typically this will be forgotten by the project planning. And that can cause a big problem at the end of the project. And also some customers may ask us to provide consultations. And they would like us to provide some knowledges. And sometimes they even need us to be presented during the audits or validation process. It's very important that all those things are planned at the beginning of the project. So this safety standard recommend us to use a safety plan. So something also mentioned by ISO 26262 standard. So in that safety plan, the safety responsibles shall help the project to identify all the potential deliverables and also plan them for the discipline teams. And I remember there will be a lot of iterations in functional safety development. Actually, it's quite common for all kinds of development. So it's very important that we listen to the feedback, to have a short loop for this iteration, and also use change management. And this is very obvious, but also quite important. Even you are under a high time pressure, don't skip the change management. It will really helpful at the end of the day. So challenges. Interpretation of the standard. It is particularly true if you are the first-time reader of a functional safety standard. So it's very important to understand the scope of the functional safety standard. We need to understand what requirements are applicable to us. And also, we need to understand the intention of the safety requirements. So it's very common that at the early of the development, at InMotion, so lots of discipline engineers are so overwhelmed by dozens of safety requirements specified in the standard. It's really hard for them to understand how to apply those requirements in their day-to-day work. So then we have to really help the discipline engineer to understand the intention. What it is asking from the standard. And sometimes it's quite useful to read other safety standards. 13849, it's relatively short functional safety standards. Already inside the standard, it refers to many other safety standards like IEC 61508, and even. And then my personal experience is that sometimes you can learn quite a lot from the ISO 26262 standard as well. That helps me a lot to understand the 13849 standard. So don't be afraid to open a more complicated and demanding safety standard. It is bigger, but it explains things in a better way. So if you are experienced company, sorry, if you have been working with the functional safety standards, and if you have customers from both automotive industry and also industrial applications, then you would like to have a common platform. And this is what the ZAPI is trying to achieve. So then often, people choose this lockstep multi-core MCU as the MCU platform, because you can find such a solution that is designed for ACOD, which is one of the toughest safety integrity level to reach. So it is even prepared to reach ACOD. However, if you choose to follow the ISO 13849 standard, sometimes you find out that, okay, it's really tricky to argue a high category classification for your architecture. So I'm not going to talk about the details, so you really have to go deep down to the technical solution about this one. But what I can say is that, okay, in this case, it's always good to have early discussion of your concept in mind with the certification authority. This is highly recommended by 13849 standard. And integration of out-of-context development. So one of the most challenging part of this safety standard is that there are just so many different kinds of machine configurations. So it's really hard for a subsystem provider to come up with a low-cost universal solution that can satisfy everybody's needs. So if you develop your system to a very high performance level requirements, then it may become quite expensive for less demanding customers. So how to solve that problem? What we are looking for is that we are developing modular subsystems that can be configured for different needs. And to reach that goal, actually, we really have to collaborate closely with the machinery manufacturers. We are trying to collect all the information, all the needs from the markets in order to implement something that is cost effective and also easy to configure, can fulfill the needs of as many customers as possible. Yeah, a short conclusion. So I have mentioned several times that it's important to understand the scope and also the intention of a functional safety standard. It's very good to have a systematic approach for the management and also for the development. Remember, the functional safety is not only for mitigating random hardware failures or dangerous failures. It's about how to avoid the systematic faults. Developing guidelines and the methodologies can help a lot for the organization. Communication is super important. It's really worth to spend a lot of time at the beginning of the project with the customer. Try to understand every single thing they have in their mind. And continuous improvement. So it's an iterative thing, not only for the technical solution, also for the company process. You will always able to find things to improve. Okay, thank you.
Okay, great. Thanks, Shuang. It's a terrific presentation there. And now we're going to go to some of the questions that have been submitted by our audience. Again, if you have questions for Shuang, now is the time to submit them in the Q&A tab in the top right. So I'm going to start with the first one. Shuang, do you know how the OEM can do this hazard analysis before refining the safety requirements or safety goals?
In an ideal world, they will contact the subsystem providers, and they first they will start from a system FMEA. So what they should ask us actually is to provide the information about what functions the device is designed for, and the malfunctions that the device may end up in. So the failures of our product. So based on those information, they need to how to say, understand the consequence of such failures at the machine level or vehicle level.
Okay.
Just one example for a HARA practice. So let's take one example. If we are producing a inverter used to control the AC motor to generate torques, and then the OEM usually integrates our inverter together with a vehicle ECU, electrical motor with sensors to implement a transmission system. And that will be used at the vehicle level. So in this system, the ECU may misinterpret the pedal input or the brake input, or simply just have a malfunction that providing very wrong requests to the inverter. And the inverter may have internal failures, so it may read the wrong sensor inputs or having a malfunction in the MCU. So in the end, it will produce the torque that the driver is not asking for. So at this item level, which is the transmission system, it will produce unintended torque. It's not asked by the driver, you can say. At the vehicle level, what the driver will experience is that the vehicle starts to either accelerating or deaccelerating by its own. And that is the hazard at the vehicle level, because you may crash into a car, into a pedestrian, or just brake really hard on highway, have a rear collision. So that is the way the OEM shall do a hazard analysis. I hope I answered your question.
Okay, was that the second question, Shuang? That you went ahead and answered that. Can you reuse the HARA of an automotive part that will be used in ISO 13849 without arguing that HARA with ISO 12,100, which is specifically mentioned in ISO 13,849 Part 1. So that was a bit of a mouthful there. So did you answer that one?
Well, there are some differences between 26.26.2 and 13.9. So 26.26.2 is safety goal oriented, and the 13.9 is safety function oriented. So the HARA done according to 26.26.2 will give you the safety goal. Something like avoid unintended acceleration or deacceleration. And then 13.9 typically will come up with something similar, but the results might be that, okay, you need a safety function to, in case that the vehicle already start to move unintended, how do you detect it and mitigate? 26.26.2 is more demanding. It's simply asking us to avoid having the unintended acceleration in the first place. So if you understand the difference, then I think you may able to reduce the HARA, but you will probably twist the results a little bit.
Okay. So any other questions that people might have? Okay, I think that that brings it to a close. Okay, all right. Well, thank you very much, Shuang. That was terrific, terrific presentation. I've just posted Shuang's LinkedIn profile into the chat. So if you want to connect, if you have any further questions, thoughts that arise, you can reach out to Shuang and connect with him on LinkedIn. So that brings this session to a close. But on behalf of the ZAPI group, we'd like to thank you all for taking time out of your busy day to attend today's session. We really appreciate it. And hope that you can tune in to any remaining sessions that we have on our second day of our Future of Electrification conference. In any case, we wish you well. Have a great day. Have a great night wherever you are, and take care. Thanks very much.